Hello viewers, you are welcome to this video lecture. I'm here to present the 11th video lecture from chapter 3. Chapter 3 deals about the geometrical design of the highway. In the previous videos will be deals about the introductions as well as the design control criterias. In design control criterias will be deals about the functional classification, terrains, design vehicles, density, design traffic volume and composition. Design speed is also deals in design control and criterias, and also will be deals about the highway cross-sectional elements. In these cross-sectional elements will be also deals different elements, for example the traffic lane, carriageway, shoulder, drainages, right of way, different barriers at the medians as well as the roadsides. Also will discuss detailed the cross-sectional elements. And also the previous videos will be deals about the elements of geometric design. There is three main geometric design parts. We deals about the sight distance, majorly design the horizontal and vertical alignments. So today's will be deals about the horizontal alignment. So we have deals about the alignment. So in highway design, all geometric elements should be skillful economical practices designed to provide safe and continuous operations at the speeds. So from those design controls, different design controls, functional classifications, speeds, vehicle dimensions, and traffic volume is very important. It is design speeds, and also designs of the horizontal alignments. There is different relationships between the design speeds and curvature, and also there is a relationships between super elevation and side friction. It is elaborated as mostly a minimum radius is equal to v square over 127 e plus f. So these formulas will be elaborate the relationships between speed. Is, for example, speed is increased, the curvature or r minimum also will be increased. The super elevation will be decreased, the curvature also will be decreased. So it is different relationship with speed. It is direct relationships. With super elevation is indirect relationship. So we have this design horizontal alignment. There different elements will be designed. The first is a tangent or a straight sections, the circular curves, transition curves also very important. Lastly will be design the super elevation. So first element in design horizontal curve is super elevation. So this super elevation is a rising of the outer edge of the roads along the curves in order to contrast the effects of centrifugal forces. So this super elevation maximum value is controlled by climating condition. For example, the climate condition is dry and wet. It is different super elevation. For example, the road is climate is very wet, the friction will be decrease, so the super elevation will be increase. And also will be the terrain condition is very important. For example, in flat areas the super elevation is high related to the mountainous terrain condition. The area also very important for the maximum value, mostly in comparing a rural area with urban area. Rural area provides higher super elevation because of the speed is increased. So the speed is increased, the centrifugal force will be also increased, so provide the super elevation will be more rise the outer edges. Frequency of very slow moving vehicles also will be related, and also the minimum value is related logically with the drainage requirements. Mostly it is provide 0.1 meter per meter. In era manuals also maximum super elevation is provide 7%. In urban areas will be decreased super elevation as 5%. And also the application of super elevation. Super elevation is provide two stages. The first stage is neutralize the cambers of the road gradually. So this means the road is initially there is a camber slope, for example 2%. So approaching the curves, the super elevation is the outer part will be 0. From normal super elevation to 0, it is first stages, and the second stage is the slope gradually until the design super elevation means from normal or 0 slope to the maximum slope is the second stage. As you see in the figures, the first is a normal cross section, so it is provided to up to 4% will be provide camber slope. So gradually entering to the curves, the outer part will be this one. So the outer part will be rise up, and it is provide 0%. The inner part is still the same. So in, this part is the first stage, and the second stage is from start from 0 up to the maximum part. So there is 0 slopes entering to the curves. The 0% will be it is positive 2 up to 4%. There is straight with inner parts, so 2 up to 4. Increasing the slopes is 6%. Maximum slope is at 10. So after that we have the curve, it will be end, so we have a reverse or return to maximum 4%, 2.40, 2% again will be the same with existing normal slope. And also super elevations development stages, so divide the two stages with their lengths. And also super elevation is developed by rotating the roadway cross sections along some axes, most commonly the horizontal center line. So super elevation development length means the length required to rotate the pavement from the point of normal crossfill up to the full super elevation. So this super elevation development length is divided into components. The first is run of length. This length is from the point there is 0 or 0 cross section to full super elevation. And run out will be it is a length from the normal crossfills to 0 crossfill, so the outer part will be 0. So we have seen in the figures, this is a normal crossfill to up to 4%, so the outer part will be rise, so it is 0%. It is still this one is 2.2 up to 4%. So from this up to this length will be run out. So runoff means from 0 up to maximum super elevation will be run out. So we have discussed the distances. So the first is the horizontal curves. The horizontal curve is one of the two important transition element in geometric design. It connects two tangents of the roadway. So there is a difference in directions. So for example, one road is going to north and the other will be going to from east, so there is a sharp curve. So provide those sharp curves will be provide a smooth turning. So this one is horizontal alignment. So the design of the curve is depending upon the design speed. So the design speed is increased, the minimum radius will be increased. So the first is horizontal tangents. That horizontal tangents means the straight line terms their lengths. So this is a tangent. For example, this is with transition curves and without transition curves. Transition curves will be provide between tangent and the curve. So this one is a straight line, so this one is straight. Provide a circular curve and provide transition curve and provide circular curve, provide circular curve. This one is as examples of reverse curves. So this one is also examples of reverse curve. So this one is a circular, there is a transition. So in this case there is no transition curve. So the purpose of transition curve is more for a safety and more adapt the curves. So directly tangent to the curves, there is a difficult for the driver. So provide the transition curve. So exercise curves and entering the measure curves. And also it is a compound circular curves also will be this one. So this one is two horizontal curves will be combined in different radius and in the same direction. So this one is a compound curves. For example, there is a first curve and this one is a second curve. So the first curves will be their own radius 1 and the second curve will be radius 2. So two curves will be combined together, it is a compound curve. Mostly compound curve cannot be avoided, so it is possible we have avoided. So with not avoided, more when we preceding the smaller curves, preceding the large curves is acceptable. So first will be provide the smaller curve and the second provide the larger curves. So the smallest curves and radius between the smallest curves and the largest curves is not more different. Only the smallest curves will be 2/3 of the radius of the curve. And also there is a change in design speed related to the curves. So in these cases, the difference between the smallest curves and the largest curves is 5 km/h. The other is broken back curves. So this one is two curves will be combined in the same direction. Between the two curves there is a tangent is provided, short length of tangent will be provided. This also will be avoid is possible. It is not avoid, for example, unusual topography of or right of way condition dictate otherwise. Driver usually does not anticipate successful curves in the same direction, so If possible, it is avoid. It is not possible, depending upon the topography is provided. A broken back circular curve is it is a reverse curves. So two curves are in the opposite directions with a short of tangents or not. It is provide reverse curves. The first is at the top, and the end is other curve is at the down. So reverse curves should not be used unless there is insufficient distance between the curves. Always will be provide a tangents between the curves. And also it is a circular curve. It is a simple circular curve. It is mostly with recommended curve is a circular curve. This one is only one curve is provided. This one is a tangent. So this one is a horizontal curves. There is a radius r, and also central angle delta. Also this one is the same, and there is a length, curve length, and also the shortest length also will be c. It is a chord length, and also external distance from the point up to the curve, and also middle ordinates will be the chords or the straight line up to the curve will be the middle ordinate. And the curve begins at the tangent to the curves, and also will be ends at the curves to the tangent. The degree of curvature may be divided into two: 100 feet arc, and also will be the chord definition also 100 feet chords. The relationships between the radius and the degree of curvature is this one. It is arc definition. Arc definition will be provide 100 feet. There is a degree d1, and also chord length means it is the chord length, the shortest distance between the preceding lines. And also chord length will be determined by degree of curvature is equal to 5729.58 divided by the radius, and will gates also will be calculated as the length of the curves also will be 2 pi r delta over 316. And also we'll have calculate the tangents. The tangent equal to radius tan delta over 2, and also will be gets the middle ordinates is equal to r minus r cos delta over 2, and external distance also will be get r over cos delta over 2 minus r. We have using use common r's, r in the bracket 1 over cos delta over 2 minus 1, and also the shorter distance between the beginning of the curve and ending of the curve is a chord length to r to radius sine delta over 2. And also will be the design standards for horizontal curves establish their minimum radius. So this minimum radius will be related to r minimum is equal to v square over 127 in the bracket e plus f. So this minimum radius of horizontal curve is a relation with the speed, super elevation, and the friction. And also will be deals the sight distances. So there is a driver eyes, so we have entering to the horizontal curves where it is free, so we have c in this distance, so this one is in this distance, so this is r, this is r, this one is the site distance. So mostly these parts will be recommended as a free from buildings, trees, any obstacle will be it is free or avoid. So the minimum stopping side distance also will be recommended. So this setback distances m means from the inner part of the curve up to the obstacle. So m will be calculated. S means the side distance, it is the distance of the curves. So we have calculated in these cases. We provide the minimum side setback distances as well as the minimum radius. And very important part is the transition curves. So the transition curves is different from the circular curves. It is the radius is always changes. So this the need for transition curves is mostly the as previous discussed, the circular curves is provide between tangents. So the transition curves is provide between the circle and the tangents. So it is introduce those forces gradually and uniform to entering to the curves. So from circular curve provide without transition curve, so the driver will be travel on the tangent directly will be the curve. There is a transition curves, there is a tangent transition curve and going to the curve. So this is a gradually and smooth, so there is increasing the safety. Transition curves have much more complex formulas, more difficult to set out on site than a circular vary radius. So to introduce, the first is introduce gradually the centrifugal forces between the tangents and the beginning of the curves. It is more for pedestrian comfortable safety, and also to enable the drivers to turn the strings gradually, his own comfort and security, and provide gradual introductions of super elevations, to provide gradual introduction of extra widening. Extra widening is provide the inner curves, so mostly for there is a large tracks, so the front wheels is not the front wheels and the inner wheels. The inner wheels not follow directly the front, so some the inner wheels will be out of the curve, so mostly provide extra widening. Aesthetically appear for the roads. The use of the transition curves, there is two type of transition curves. So it provides the composite curves as well as the whole transition curves is provided, and the type of transition curves also will be provided by using the transition curves, clotite and cubic parabolic is used. The length of transition curves will be, it is depending upon the rate change of centrifugal acceleration. So the acceleration will be, centrifugal force will be increase, the length of transition curve also increase, and also introduction of the super elevation. So super elevation very high, the length of the transition curves will be increase, and also will be calculate the length of transition curve by empirical formulas. And setback distance is the distance between the center, the inner part of the curves up to the obstacle. So this distance will be denoted by m. So this one is provide for horizontal curves. So it is for the first one is for purpose of stopping side distance, radius of the curves, and also depending upon the length of the curves. the length of curves is short, so uh, the curve will be m will be greater. And curve resistance also will be a vehicles negotiates a horizontal curve. The direction of rotation of the front and rear wheel is different, so it is provide the curve resistance. So this for transition curves will be these parts. For example, this is a tangent. uh, there is a transition curve, and the other is the main curves, and there is a transition curve and tangent. So it is provides tangent transition curves. It is between the circle, and the tangent is more smooth and gradually flow of traffic. Thank you for hearing my presentation.